Now these six birds, 1, 2, 3, 4, 5, 6, are to be put into 3 cages such that bird number 1 and 2 should not be together, 2 and 3 should not be together, 3, 4, 4, 5 and 5, 6. So these pairs should not be together. So if I'll make different combinations, bird number 1 with bird number 3, then 2 and 4 cannot be together, because if we'll put 2 and 4 together, we have to put 5 and 6 together, which is not possible according to the given condition. So I can put 2 with 5 and remaining 4 with 6. Then next, if I'll put 1 with 4, so I'm putting now 1 with 4. So now I can put 2 with either 5 or with 6. So 2 with 5, then 3 will be with 6, and if 2 is with 6, then 3 will be with 5. So we have 2 cases when 1 and 4 are put together. Now the next case, if 1 and 5 are put together. So if 1 and 5 are put together, 1 and 5 are put together, then we cannot put 2 and 3 together. We cannot put 3 and 4 together. So I have to put 2 with 4 and 3 with 6. So 2 will go with 4 and 3 with 6. And the last case, if 1 and 6 are put together. So if 1 and 6 are put together, then 2 will go with 4 and 3 will go with 5. So 2 will go with 4 and 3 will go with 5. So now we have these different 5 cases in this question. Now looking at question number 1, it says none of the 3 pairs can be determined with certainty if it is known that x1 is put together in the cage that is also has a key. The question is, which of the following can be put with x1 in one of the cages so that the pairs in the remaining 2 cages cannot be determined uniquely? So looking at these 5 cases that we have made, if I'll put bird number 3 with x1, then there is only one case and I can determine the birds in the other 2 cages uniquely. Similarly with x5, bird number x5, again there is only one case, so I can determine the birds in the other 2 cages uniquely. Similarly with bird number 6. So if I'll put bird number 1 with bird number 4, in that case, since we have 2 cases here, so the birds in other 2 cages cannot be uniquely determined. Now next question. If a pair of birds kept in the same cage is known to us, then we have to find the probability that the other 2 pairs of birds kept in the remaining 2 cages can be determined uniquely. Now let us separate out those cases in which if one pair is known to us, we can determine the other 2 pairs uniquely. So these pairs are, like, if I'll take 1 and 3, if I'll put 1 and 3 together, then I can determine the other 2 pairs uniquely. So one of the pairs is 1, 3. If I take 1 and 4 together, then other two pairs cannot be determined uniquely. If I take 1 and 5 together, other two pairs can be determined uniquely. So next one is 1 and 5. Similarly, 1 and 6 can be taken. 1 and 6. 2 and 5 cannot be taken. If 2 and 5 are put together, I cannot determine it uniquely. So 2 and 5 cannot be together. 2 and 6 can be taken. So next pair is 2 and 6. 2 and 4 cannot be taken. Similarly, 4 and 6, if I know about this, I can determine the other two pairs uniquely. So another case can be 4, 6. I cannot take 3 and 6, I cannot take 3 and 5 because both have two different cases. So these are 5 cases in which if I know one of the pairs, I can determine the other two pairs uniquely. Now let me write set of pairs in which if I put the birds together, then I cannot determine the other two pairs uniquely. One such pair is 1, 4. So if I put 1 and 4 together, then the other two pairs cannot be determined uniquely. So one such pair is 1, 4. Another pair is 2, 5. Then another pair is 2, 4. And there are two more pairs, 3, 6 and 3, 5. So the probability that the other two pairs of birds kept in the remaining two cages can be uniquely determined will become 5 over the total number of cases, which is 10. So it will be 5 upon 10, that is 1 upon 2. Next question. If the bird kept in one of the cages are x2 and x4, so they are talking about these cases. So these two cases we have to consider. So if x2 and x4 are put together, then the question is which of the following pair of birds are not kept in the same cage. Now looking at this, 2 and 4 are together, then I can say that 1 and 5 are together, so option number 1 cannot be the answer. 1 and 6 can be together, option number 3 cannot be the answer. 3 and 5 can be together, option number 2 cannot be the answer. So I'm left with option number D, that is 1 and 3. So this should be the correct answer.